Hello everyone, so I am back and let's start this. So this was initially prompted to me as with this comment where it gave the idea for you of instead having to calculate the square distance of two objects. So in theory, this formula should be faster than just calculating the distance squared too. I'm also going to teach you how you can do benchmarks with your own functions. So we're going to actually see if this is faster than the GDScript function square distance. So let's actually test this and see if this works with GDScript. So this is the scene setup. We have two objects here. We have a camera and our sunlight and the environment. So let's start by adding here a script to our main tree node here. So let's go to our script, new script, and let's save as main. So let's work here with the function of pass. So let me just clean this up. We are not going to need it. So the first step with this is the idea that we want to calculate the distance between the two objects. So let's we add here a reference to these two objects. So on ready var, which is going to be equal to our cube, and let's duplicate this line with Ctrl+Shift+D, and let's rename this to sphere, and let's replace this with our sphere. Let's build the function that's going to benchmark test your other functions. And we're going to do this using a callable. So I'm going to explain very briefly about this, but if you want to learn more about it, search for tutorials on callables. Basically, it's functions. So let's do a function here that's going to say benchmark function. And we're going to need a function to be benchmark, which is going to be a callable. And a callable is basically a function object. And this function is not going to return nothing, so that is why we type void in there. And let's do the benchmark. So we first need the func start time. So this is going to be a float. So the start time we're going to be getting from the time server. We're going to get the msec time stick. So this function is getFic times msec. So this returns the amount of time it has passed in milliseconds since the engine started. The difference between this and a func end time is going to be the amount of time it passed after we call our callable function. So on the middle here, we are going to actually execute the function we called. And this should allow us to grab the initially starting time and the after time after the function has been called. And by printing the difference between these two, we are going to actually be seeing them how the amount of time it took for this function to run here. So let's do another var and let's say func time difference in seconds. This also is going to be a float. So this is going to be simply the func end time less than the func start time. This difference is going to return us the amount of time it took to run this function. But it's currently running on m seconds. So I like to see stuff in seconds. So I'm going to multiply this by 0.01. And this should in turn return us with a function time in seconds. And we're going to simply finally print and say that took that function in seconds. So let's go right here, and on here we're going to pass the func time in difference in seconds. So this should allow us to calculate the difference time between the ending time and the start time. This difference is going to tell us how much time has passed after we have executed a function, which is going to be the calculate of the distance we are going to run. So in order for you to call callables, you are going to need functions to be called without arguments. So you cannot pass arguments to callables. So the way we can do that is by using a lambda function. So let's say here that we want to benchmark a function. So let me just paste here the distance, the first method we are going to be using to calculate the distance. So this is the standard way that I did on my project and that I think was the fastest one. So this method is simply calculating the distance between object A, global position, the distance squared to object B, global position. And is going to return if the distance of those two objects is less than a given minimum distance, which we pass as arguments. So if that is the case, we're going to return true, otherwise we're going to return false. So this function returns a Boolean value that we can use. So in order for us to benchmark this, we are going to need to input the arguments you see here, an object A, B, and the minimum distance. We cannot do that inside of this function because it only accepts as argument the callable function. So we cannot do function call. And because we don't know what the function is going to be called, we do not can pass any arguments. So in order for you to do that, we're going to run our function callable. And inside of this, we're going to generate a new function that is going to supply the arguments needed to calculate this function here. So let's do a func here, which is going to return as void. And this function is simply going to call this method 1distance for a given amount. So the object A is going to be our cube, the object B is going to be our sphere, and the minimum distance, let's put something like 20 to start with. Now this is going to run the function only once, and the benchmark is going to return almost 0 because it's just running it once. So in order for us to have a better system to test this, I'm going to run this function for a high value, like something like, let's say, 100,000 times. So 100,000 times we're going to run this function here. So this is how it's going to run. First, we are going to be running the benchmark function. The benchmark function is just going to execute a function inside of it. First, we save the starting time. Then we run the function, we pass it. Then we're going to calculate how much time has been passed. And the difference between the end time and the starting time is going to return us how much it took to run this function. Then we're going to multiply by 0.01 to return that difference in seconds because this function returns us with milliseconds. And finally, we're going to print how many seconds that difference took. So this is going to allow us to see exactly how many seconds this function took. So now if we run this scene, we should be able to see how many seconds it takes. And as you can see down here, it took 0.158 seconds. So this is how you can benchmark your functions as you see fit. So now that we have done this, I'm going to put them together just like this, and I think I can actually group everything together. This is less readable but more compact way of running the function. So now we can start to add more methods and call them here to see which one will be the fastest one. Let's go ahead and do the distance we saw with this comment here. So this is the second method that does exactly what that comment has spoken about. So this grabs the sum of the two different x positions and the sum between the two z positions, and we're going to classify that as y. Then next we're going to sum them together and see if they are lesser than the minimum distance powered by 2. If that is the case, we're going to return true, otherwise false. So this is the same idea with the other function. But instead of using distance squared, we are going to calculate based on this formula here. So now we should be able to just duplicate this function and switch this to method distance2. And we're going to see how many seconds that's going to take. So this should allow us to test if this is going to be faster than this one. Now if we run, we're going to see that no, it actually is not. So the first function we call the method distance1, which uses distance squared, is actually faster than this one. But it should not be. Why that is the case? Well, simply put, because this is a built-in function inside of GDScript, it is actually being called with C++ code. So now I have added a bunch of different functions that calculate distance, and we are going to see if they are faster or not. So we are going to see, based on all these different ways to calculate the distance between two objects, which one is the fastest one. So I experimented with a bunch of different ideas, and I think you probably can come up with more ideas to see if they are faster or not. So as you can see, these were the two methods we started with, and I have added some different ones. For instance, this one does not store the difference with variables, it just calculate based on a if, and I also does a power of 2 with the two different positions. This one is also a little bit different. This one actually saves the global position as variables, etc. So let's see which one of these methods is the fastest one. So as you can see here, we're benchmarking all of those functions 100,000 times. So I'm going to replace this with something a little higher. So let's put 250,000. So 250,000 calls is going to call for these functions, and we're going to see based which one is the fastest one. So let's run this one and let's analyze here which one was the fastest one. So let every single one of them run. And as we can see here, and it's actually a little hard to know the difference between each one of them. So here's something I'm going to do to just make sure I know which var is going to be. So let's do ix, and this is going to be an integer, it's going to start at 1. And the idea with this is actually, let's put it as 0. And we are going to be printing this inside of here. So I know exactly which method I am running. So after we have been calling the function, we are going to add to ix just 1. So this is just a little hack that I'm going to do to know which method function I'm calling. This is going to add an integer at the beginning of every single one. Okay, now we know which function is being called to what. So as we can see here, based on the results, the fastest one is the method number 10 and method number 8, which almost does the exactly same thing. So the method number 8 calculates the distance square between A and B. However, we are not passing the node reference, we are passing the vector instead. So this was something I did not know, but actually makes sense. Instead of passing object reference, if you pass the vector that you're using to calculate, it's going to run much faster. As we can see here, they almost double the performance from 400 to 271. So this is actually some pretty cool stuff. Something that I thought was actually going to work faster, but it did not, was converting the position to a vector 2 to calculate the distance squared. And if we check how we created that, we created a new vector 2 on runtime with the 2 reference positions, and we passed that as an argument to the function. So that actually was slower than just running with the global position vector 3. So also something that was worthwhile to test. And the worst performing function was number 6. So what is number 6? Number 6 created a bunch of variables using floats. So let's try another method here because I just have the idea. Let's implement a method 11 here, and I'm going to see if passing the vector 3 position is actually faster. So instead of that, we can simply use A. So let's see if this is actually faster or not. So let's duplicate this function and let's call it as number 11. Let's run this. So I'm actually quite curious if this is going to run faster or not. And it does not. Interesting. So I have seen some people on the internet claiming that using floats instead of vectors was actually faster. That is not the case with GDScript, probably because we have to create this bunch of different vars here. So interesting. So you can see how that works. So you can also continue to experiment with these and add more and more methods and to find which one is the fastest one. And this can also work for a whole bunch of different function types. So if you want to optimize a function, this should be able to help you. You have actually learned the fastest way to calculate the distance is this one right here. Calculate based on vector frees, and we use distance squared too. So if you wanted, you can also try to implement this stuff that this guy mentioned in C# or C++ in Godot and see if it runs faster. My guess is this will actually run faster. But in GDScript, because we are using built-in functions, we're actually running C++ code underneath. That's why whenever we try to do the method through GDScript like this, it actually runs slower than the first one right here. That is how you can actually optimize your code and to make. So that's about it. Hopefully you guys enjoyed, and I'll see you on the next one. So thank you guys for watching.